In this presentation, I'll be explaining different applications of solar thermal system. This is a part 1 in which I'll be explaining regarding the solar water heater and space heating, that is, and space cooling. Passive space heating and space cooling will be explaining in this presentation. Now let us see the solar water heater. Solar water heater, this is the schematic diagram of a solar water heater in which a tilted flat plate collector is used to in solar water heater to collect the solar radiation. A flat type collector is used, that is tilted one, that is solar radiation is falling on this one, that converts that into the heat energy. And in order to transfer this heat energy, there is a heat transfer fluid is using, that is water is the heat transfer fluid. Therefore water is coming from the hot water. This is an insulated hot water tank. From that one, that water is coming to the in the flat plate collector, and then heat is being transferred to this one water, and then that heated water is coming to again hot water tank, which is thermally insulated one. This thermally insulated hot water tank storage is mounted above the collector. That is, this is the collector, and this tank is kept above the collector. And the heater water tank of the collector rises up to the hot water tank. Therefore, here the heated water that from the collector that will be rising up to this hot water tank, rises up to the hot water tank and replaces equal quantity of the cold water which enters to the collector. And the same amount of water is coming from the cold water that from the tank that comes again entering to this collector, and that gets heated. Therefore, this is the process that which the water is coming from the hot water tank, again that is passing through the collector, and that is heated up, again going to the hot water tank. Therefore, this cycle repeats and all the water of the hot water tank gets heated up. This is repeating, and all the hot water of this tank is getting heated up by this process. And when the hot water is taken out through the water outlet, that is when we are taking out the hot water from this through the outlet, the same quantity of water is coming from the cold water makeup tank, that is cold water that is coming to the hot water tank. Therefore, the same quantity of water is replaced by the cold water from the cold water makeup tank. The cold water makeup tank, same amount of water is being replaced in here as we are taking out the hot water from this hot water tank. Now continuing the solar water heater, again this is the schematic diagram which I already explained, and in that one the process that is happening is called thermosiphon action. That is a cyclic fluid flow from the area of higher heat to a lower heat and back. That process we call it as thermosiphon action that is taking place here. This is a passive type of heating scheme. Therefore, naturally circulates the water, that circulates naturally through this one, a natural method. There's no external mechanics or mechanical system for pumping, it is not using. Therefore, this is a natural process that is called thermosiphon action. That is why this is called passive heating scheme. This scheme we call it as passive heating scheme as such. And this is the construction details of a solar water tank. That is the solar water tank. That is, this is a pressurized inner tank, and here of course it is insulated. Outer case of this tank and the tube rings, etc. This is the vacuum tubes, and this is a reflector, etc. The end brackets. So this is the construction details of the solar water heater. And if the collector is fixed above the, that is, if this collector is kept above the hot water tank, then a pump is required. In that case, a pump will be requiring, and to induce a circulation, a forced circulation, a forced action, it's called active solar. That is called an active thermal system. Now, if you are using a pump mechanism to pump the water, and in the if that is happening when the collector is kept above this hot water tank, then a pumping mechanism is required to circulate the water. Then that type of that we call it as solar thermal system, we call it as active solar thermal system, and when a pump is used. Therefore, here this is a passive solar water heater or passive heating scheme is used here. Now let us see an active solar heating. As I told you, the water tank, that is the collector is coming above this one. Therefore, in that case, this collector here, there is a fluid that is flowing, that is pumped through this one, and that is heat transfer fluid is there. That heat transfer fluid that is pumping through that one, through this one, to that one, that heat energy or the thermal energy is transferred to that fluid, and after getting heated, the color we can see that will become red. Therefore, this is a heated fluid that is flowing that one. Therefore, heated fluid is flowing, and that heat is transferred through a heat exchanger. That is, a cold water is coming here. That heat is transferred to the cold water, so that we'll be getting outside a hot water is available here. Therefore, the same thing can be given to a boiler, so that temperature of that can be transferred to the boiler also. That heat energy can be transferred to the boiler also. Therefore, this is an active solar heating system in which we are using a mechanical pumping mechanism is there. That's a controller of this pump. Therefore, here, that is why it's called an active solar heating system. Heat a fluid in order to provide hot water or a space heating. Uses a mechanical system, that is a pumping mechanism is used. Generally includes thermal mass to store the heat. Therefore, this is a schematic diagram of an active solar heating. Now let us see solar space heating and cooling system. Solar space heating, that solar passive space heating and cooling system. That is, solar energy is used to maintain comfortable temperature inside the building by means of heating or cooling inside as per the requirement. For transport of heat, mechanical devices are not used. In the space that is solar in passive heating methods, there is no mechanical devices are not used. That is why it is by natural process of conduction, convection and radiation. That is, in passive space heating, there is no mechanical pumping mechanism is not used. By means of natural process, the heat is transferred to the space. That is called solar passive space heating and cooling mechanism. For building is designed so as to make flow of heat naturally. That's called a solar house. But in active space heating, solar active space heating and cooling mechanism, in active heating, mechanical devices like pumps and blowers are used to circulate the working fluid or transportation of the heat. We are using mechanical devices in active space heating or cooling system. Therefore, in that case, there's no special building design is not required as required in the case of passive heating. In passive space heating, the building is to be designed in such a way that the natural cooling or conduction and convection radiation transfers the heat energy into the space. Therefore, there is no forced circulation of, unlike the active space heating. Therefore, special building design is not required, is not necessary as in the case of a passive heating in active heating and cooling system. Now, continuing solar passive space heating, in this case, this is a heat is transferred by natural conduction, convection and radiation without pump or fan. We are not using any pumping or fan, pumping mechanism or any fan power. In that one, by natural means of conduction and convection and radiation, the heat is transferred. Therefore, this is the Trom wall. This is the Trom wall is this one. This wall is designed that is facing the south, a thick wall made up of concrete, stone and brick blocks designed for the thermal storage. This is made for a thermal storage. Same thing, this one, thermal storage that is made. Outer surface is painted black in order to increase the absorption rate. Therefore, the outer surface of this one is painted black in order to increase the absorption rate. Therefore, solar radiation is falling in this one. That is available. That heating this area between this glass case, glazing, as well as trompe that is black, and that is it's a block that is painted with a black in order to increase the absorption rate. The solar radiation is reaching here. We'll see in the next slide the continuation of this one. Now, continuing the solar passive space heating here. Here the same thing as we have seen here, and here the solar radiation after penetration through a glazing is absorbed by the thermal storage. So this is a thermal storage wall, as I already explained, and here this is the glazing wall, and the solar radiation is penetrating through the glazing and is absorbed by the thermal storage. This is a thermal storage wall that absorbs that one, and air in the gap between the glazing wall that is the air between this gap air, that is getting heated, and that rises up and enters, that air is getting heated, that enters the room through this one. The heated air is coming through the upper vent, that heated air is coming here, and the cool air, that is cool air from the room, that is from the cool air from the room is it replaces it through the bottom vent. The cool air is coming here, that is getting heated and that is rising up. That hot air is coming to the room. Therefore, the thermal wall collects and stores and transfers the heat to the room. Therefore, this is for the heating purpose. The heat energy or the thermal energy due to the solar radiation that heat this region, air between this one, that rises up and that is going through this room, and the cold air is entering to here, that is getting heated up. This circulation happens, and by controlling the airflow through the inlet and outlet vents of the shutters, by controlling the airflow here and here, the heating can be adjusted. The temperature of this room can be adjusted by controlling this upper vent as well as lower vent. When heating is not required, the damper at the top of the glazing is open to allow the excess heat to escape. If no heating is required, this is open and the hot air that will be going outside that one. Therefore, when heating is not required, the damper at the top of the glazing is open to allow the excess heat to escape to the outside, that is to exit from the outside, that one. Continuing the solar passive space heating, the same schematic diagram itself, and this is the building, the room as such, and this is the wall, and here the solar radiation is falling from the glazing, and this is getting heated. That hot air is coming into the room, and the cold air is again coming back. This is being circulating, that one, and this is passive solar heating with a trombe wall. This is the trombe wall that collects the thermal radiation or thermal energy of the solar radiation is collected here. That air is getting heated. Therefore, this is towards the north side. For another pictorial representation of this solar passive space heating system. Now let us see the next one, solar passive cooling system. In solar passive cooling system, that again the diagram is shown here, in which to achieve the natural cooling, reduce the thermal sources entering the building. For example, direct sunlight entering the building can be reduced by, that is direct light entering to the sun, the building can be reduced by sun breakers. We are using the sun breakers or shading of on the window walls and roofs, etc. By providing this one, the light that is falling on the building can be, or entering the building can be reduced by this. What's the one method, natural method of reducing the light entering to the building? First one. Second, conduction of the heat by providing thermal insulation. That is, by providing the thermal insulation, the conduction of heat can be controlled or reduced. Then, infiltration of outside warm air can be reduced by proper sealing. By providing the proper sealing, the infiltration of the outside warm air can be controlled. Therefore, this is the three methods to reduce the direct sunlight entering the building. Therefore, this is a passive type of cooling mechanism, or that it is shown here as such. This one, say how you can reduce the temperature inside the building or space. Continuing the solar passive cooling system, the common methods for passive cooling buildings are by providing shading, of course, ventilation, evaporation, radiation, ground coupling, and dehumidification. These are the 6 methods for the cooling of the buildings. The 6 methods are there. Now coming to the shading one, first one, that is by providing the shading here. The shading prevents the heating from the direct sunlight using the reflective roofs and shades. And ventilation, that can be, second one is by providing the proper ventilation. Ventilation means warm air is driven out and cool outside air is sucked inside using the chimney effect. Using the chimney effect, warm air can be driven outside and cool, outside air can be taken into that one. That process with chimneys can be, the chimney effect can be utilized to that one. So these are a natural way of cooling the building. Now continuing the solar passive cooling through the ventilation method. This method is effective when outside temperature is moderate. This utilizes solar chimney effect. This is utilizing the solar chimney effect, and the solar radiation heats up the air between the glazing and interior south wall. Interior south wall, that is here the solar radiation, that is this is a glazing and this south wall, and that is heating this region, heating the air, and as it is getting heated, the air is going up. That is, air rises up and goes to the outside through the air duct. Therefore, as it is getting heated, that is going up and that is going outside to the that one. Outside of that one, the air rises and goes outside through the air duct, through this air duct that is going outside. And the cool warm air from the room is drawn into this one space. Therefore, the warm air will be coming again, the warm air coming to from this region, and that gets again heated up, that is cool going outside. And the warm air is from the room is drawn into this space, and cool outside air enters the room from the bottom air vent. That is, this is the cool air is coming from this one. The cool air is from the bottom air vent. The cool air is coming to this one, and that is getting cooling this area, and the hot air is coming through this one, that is going through this vent. The cool outside air enters the room from the bottom air vent, Thereby, this area is getting cooled by this. That is all by natural method of cooling technique. Next is the solar passive cooling system, continuing that one, that evaporation. Evaporation means effective in dry region. Cooling is maintained by using the internal heat to evaporate the water. When evaporating is what is passive evaporation cooling wall constructed by cooling material. By cooling the cooling material, that when it is evaporating, that is cooling the space near to that one. Therefore, that is the evaporation method. In radiation cooling, black plastic water bags kept over the metal roof, and they are exposed to the sky at night. Radiation cools the water during the night, and this water absorbs the heat from the space below it and maintains it the cool. And during the daytime, the roof is covered by the thermal insulating sheet to prevent the heating of the water due to the solar radiation. And that is the way in which it is the passive cooling technique is made by using the evaporation and radiation cooling methods. Another one is the ground coupling. Using the ground coupling, in summer, ground temperature is lower than the air temperature. Lower temperature of the ground can be used for cooling the building by partially sinking into the ground. Because the summer ground temperature will be lower than this temperature. Therefore, in that way, by using that advantage, temperature of the ground can be used for the cooling the building by partially sinking into the ground. That is called ground coupling method of cooling the space. Here, again continuing the solar passive cooling through another method is the dehumidification method. In which, in dehumidification system, moisture content of the air in the room is reduced. That is, by cooling is maintained by absorption and evaporation. The east and west facing walls are provided with solid absorbent materials and water baths. That is, absorbent materials and water baths. That is, here both east and west facing walls are provided with this one. By use of chimney effect, air circulation is maintained. By using the chimney effect, the air circulation is maintained in the system. Therefore, during the morning, east wall is getting heated up. That during the morning here, east wall is getting heated up, and by the solar radiation. And the heated air, that is as this one, the heated air rises up and ducted outside. That is, that the heated air is rises up and ducted outside. Air is drawn inside from the west side due to the natural draught produced. That is, from the west side, the cool air is coming into that one. That air is coming into the space provided this one. The continuing the solar passive cooling through dehumidification methods. The as we have seen, as this eastern side, this is getting east side is getting heated during the morning time, that is heating this area, and the hot air will be rising, and that is going outside. And here the outside air, that is in this side, cool air is coming here, and the cool air is comes to here. That here it is getting, living area that gets cooled. Again, that is, that same air is coming here, that is getting heated and going outside. For this process is happening. This is the process by which the air is moving that way, and that's called the chimney action as something like that. And in this one, the temperature of the space is getting reduced, so that is getting cooled during the morning. It is happening like that. And the incoming worst side air first gets dried up, and by the solid absorbent, that is getting dried up by the solid absorbent is there, that is getting dried up and evaporately cooled by the passing over water baths, and then enters the, that is, this air is getting cooled up by that, that is the absorbent is there, and this water bath is there, and this air is getting cooled here. The cool air is coming in the inside to the room here, and then that cool air is coming here, and then hot air is, that is after that one, that's hot air is coming, that is getting heated up, that is going outside. Therefore here entering the cool air, and here the the air that is going out is heated up, or that is again that is getting heated up by this solar radiation that is going outside that one. This cycle will be continuing, and that is during the morning time or evening time. The reverse thing happens. This is getting heated up, and here same thing, or here air is going outside this one, here air will be coming to this one, that is cool air is coming here, and then again hot air is coming. The reverse process is happening in the evening. Therefore in the evening, the west side wall is getting heated up, this side is getting heated up by the sun radiation, reversal of the airflow occurs. Therefore here this is the process by which the the temperature of this space that is getting reduced, and that is cooling mechanism is done by natural method of that one. That is why it is called a passive method of cooling, and this process we call it as dehumidification method.